Okay, so now we are on Unit 3, Part 2 review. We're on page 3. We're doing numbers 7, 8, and 9. So number 7 says a gasoline pump delivers 4 and 4/10 gallons of gasoline per minute. How many minutes will it take to fill a gas tank that holds 16 and 5/10 gallons? Okay, so let's highlight what's important. They deliver 4.4 gallons of gasoline per minute. How many minutes will it take to fill a gas tank that holds 16.5 gallons? So same kind of idea is we're looking at 4.4 gallons for the first minute, 4.4 gallons for the second minute. So I'm taking the total of 16.5 and I'm dispersing it into, or separating it, trying to get my minutes. So when I do that, I know that I am dividing. So I'm going to start with my total of 16 and 5/10 gallons, divide it, because I'm dividing it into 4 and 4/10 gallons so I can figure out the minutes. For my estimation, 16 and 5/10, 5/10 is equal to 1/2, so that's right in the middle. When it's right in the middle, we're going to go up to 17, divided by, well, 4.4 means 4 and 4/10. Well, that means 4 is shaded out of a possible 10, which means we're closer to 4 than we are to 5. If I were to divide that, I would find that I'd have 4, but I'd have a leftover of 1/4. And we know that 1/4, that's a benchmark fraction, is 25 hundredths. So it'd be 4 and 25 hundredths, or around there somewhere. Okay, so with our problem, we are dividing decimals, something that we've been doing the last 2 days. So let's put our total in our house. Let's put what we're grouping it by outside of our house. Now notice we have a decimal outside of our house, and we cannot divide with a decimal. So I need to move that to the end, and I went one place, which means I'm going to find the decimal inside my house and move one place. So I've moved the decimal. The decimal is going to go up and sit on top of my house in the same spot. Now I can divide 44 instead of 4.4. So I notice 44 cannot go into 1. 44 cannot go into 16. But it can go into 165 3 times. 3 times 44 is 132. Subtract, I get 33. Now, I can either leave it as 33 over 44, reduce my fraction, which I could do easily. I could also add zeros to the end to make my number grow, much like when we divide up into fractions and we add zeros to make it grow. Let me show you what I'm talking about. If I were to add a 0 here, which now it's looking like $165. Remember, when I add zeros behind the decimal, I'm not changing its value at all. All I'm doing is expanding the number so that I can expand my answer and get a couple more place values. That would change my 33 into 330. 44 goes into 330 7 times. 7 times 44 is 308. Subtract, you get 22. I'm going to expand it a little bit more because I'm trying to get rid of this number. I'm trying to find where it either this number repeats, like we've noticed with fractions, or we're at a 0. So I'm going to bring this down 220, and by now that goes in evenly with 5. And so my answer is 3 and 75 hundredths. I'm going to show you, move this over, what it would look like if you just kept it a fraction. So we were at the decimal here, our 4.4. I said, can you have a decimal out of this house? You said no, so move it, bring it up, put it up here. That's where we were. We also said, can it go into 1? No. 16? No, but it can go in 3? Yes. 132, yes, 33. Okay, this is where we were at. So if you did a fraction, what you would have done is 33, and you would have written that as 3 whole and 33 44ths, which is fine, but you need to see where this can be reduced. I see numbers repeating, which you have to think, what number does that? The number 11. So 33 divided by 11 is 3. 44 divided by 11, I'll put our little 11 here, is 4. So it's actually 3 3/4. Well, what is 3 3/4 with a decimal conversion? That's a benchmark. It would be 3 75 hundredths, the same as we did here. So either way, you'll get the same answer. It's one of those that it's whatever's easiest for you. So our answer is going to be 3 75 hundredths. Okay. Oh, this is minutes, so this is almost 4 minutes. There you go. Forgot my label. Okay, next one. Number 8, Sally frames a painting which measures 10 1/4 inches long by 9 7/8 inches wide. The frame is 1.5 inches wide all around the painting. What is the perimeter of the frame? Hint, draw a picture. Okay, so we have to remember perimeter. Perimeter measures around the outside, around the outside, around the outside. Perimeter measures around the outside, add all the sides. Okay, so that reminds us, add all the sides. Now, we've got to focus on what's important. We have painting that measures 10 by 1/4 inches long and 9 7/8 inches wide. The frame is 1.5 inches wide all around the outside. Let me show you what that means. So I have this frame. It says that I've got 10 1/4 inches long, 9 7 inches wide. When it says it's 1.5 inches wide all around the painting, that means there's a frame. So like this frame is not just pencil thin, it's actually thick, so it's 1.5. We don't need that for perimeter. That's a great detail. We don't need it. I'm crossing it out. But you have to think back to perimeter. If it's 10 1/4 inches long on this side, what is it going to be on this side? Well, because they both are the same length, we know it would be 10 1/4 inches here as well. Same question on the opposite side. If this is its width, 9 7/8 inches, what is the width on the opposite side? Well, it's the same width, so I know that it's going to be the same number. So my equation is 10 1/4 times 2, because I'm going to add those. Then we're going to add it to 9 7/8 times 2. If you want to get your estimation, think 10 1/4 is closest to 10 even, because 1/4 is 1 shaded out of 4, so it's closer to 10 whole. 10 times 2 is 20. 9 7/8, well, 7/8 is 7 shaded out of a possible 8. That's 1 away from 10. So I would round this up to 10. 10 times 2 is also 20. So my answer is going to be somewhere around the area of 40. So let's see how we actually work the problem. 10 1/4 times 2. So I'm going to get this out of, I'm going to use a different color. I'm going to get this out of my mixed and make it improper. So lasso, multiply, add. 4 times 10 is 40 plus 1 is 41. Denominator stays the same. Times, well, remember, what did we discuss with whole numbers? How do we make them fractions? We agreed that there's a rule to make a whole number a fraction. We just put it over 1. I do see that there is a way to go ahead and reduce. 4 and 2 share a 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. There is nothing else for me to reduce, so I'm going to go ahead and answer. Multiply top times the top, bottom times the bottom. 41 over 2, which if I divide 41 by 2, 2 goes into 4 twice. Bring down my, 0, bring down my 1. 2 cannot go into 1 evenly, so we're going to put 0. My answer is 20 1/2. Let's flip this over. So I've got 20 1/2 for that answer. The other one was 9 7/8 times 2. Same thing, lasso. Get it out of there. 8 times 9, 72 plus 7, 79. Denominator stays the same. Times a 2 whole, remember we said we'd put that over 1. I'm going to go ahead and reduce. 2 goes into 2 once. 2 goes into 8 4 times. Cannot reduce the opposite direction. I would have 79 over 4. Let's get it out of the improper. Divide. 79, 4. 4 goes into 7 once. Left with 39. 4 goes into 39 9 times. 36. That gives me remainder 3, so that's 19 3/4. Now I said I was going to add those. If you look back at your original equation, I was going to add the totals. So I first look at my fraction, and I look at the denominator. Denominator is not common. I need to get it to common. So I'm going to multiply times 2 times 2. So I have 2/4 and 3/4. 2/4 plus 3/4 is 5/4. Add up your wholes, that's 39. This is improper, so to get it out of improper, we would need to divide. And I know that it's 1 1/4, which makes this 40 1/4. So my answer is 40 1/4 inches, or we can write it as 40 25 hundredths. Number 9. Mrs. Gutierrez bought 2 dozen cans of soda at 6 cans for $1.98 and 18 bottles of water priced 6 bottles for $2.16. What's the total amount she spent, not including tax, on soda and bottled water? So again, we have 2 dozen cans. They're priced at 6 cans for $1.98. 18 bottles of water priced at 6 bottles for $2.16. We're looking for the total amount spent on soda and bottled water. Well, this is one of those, again, that it's not just we buy 1 can of soda and it's $1.98 and I need 2 dozen. They are grouped. So I need 2 dozen. First of all, I need to know what 2 dozen is. Instead of saying 2 dozen, we're going to say that's 24 cans. So I need 24 cans. Well, 6 cans are $1.98. That means 12 cans would be $1.98 plus $1.98. So how many groups of 6 can I get with 24? That's going to be 4 groups, and I'm going to multiply that by $1.98. Because 4 groups times 6 cans gives that 24 cans. Same thing with water. I need 18 bottles, but it's not 1 bottle is $2.16. 2 bottles is $2.16 plus $2.16. It's grouped. I spend $2.16, I get 6 bottles. Well, how many 6s do I get in 18? So that's 3 groups. I'm going to spend $2.16 on each group. Now let's do some estimation. 4 is already a whole number, times $1.98. Well, that $1.98 is going to be closer to $2 because we have to go way back 98 cents to get to $1. We only need 2 cents to get 2. So we're going to do 4 times 2, which is 8, plus 3 is already a whole number. 2.16, well, 16 cents back to 2, or 84 cents to go to 3. So I'm going to head back to 2. So 3 times 2 is 6. That means I'm spending around $14. So let's do the work. These are multiplying decimals. Remember, we get to break the rule. We do not have to line up decimals. Multiply. Carry 39. 7. It's taking 2 places to get out, so 2 places to get in. $7.92 is how much you would spend on the cans. Then I'm going to look at water. 216 times 3, 18. Move this up a little bit. 4, 6. Do not forget, move it out, move it in. 648. So I have $7.92 is the cost of the cans. $6.48 is the cost of the water. I need to combine those. 2 plus 8, 10, carry your 1, 1, 9 is 10, 14, carry your 1, 8, 6, 14, and do not forget that decimal. So my answer is I spent $14.40 for soda and bottled water. Okay, we've got one more video. Check the last page. It will be on 10, 11, and 12.